Hello, so in this video we are going to be looking at sigma notation. So when we talk about sigma, this is the symbol for sigma, the Greek symbol, which means in mathematics summation. And because we are talking about series which are summations, so that is why we use this symbol. Now whenever you are given a series in sigma notation, you'll have a general formula, of course. So this is the nth term that we were dealing with when we were doing sequences as well as series. Now in sigma notation, the value below the sigma sign, that will be the first value that you will substitute in the general formula so that you get the first term. And at the top, that will be the last value that you will substitute if you want the last term. So looking below, so we have the general formula Tn. We substitute to get the first term 1. So as you see T1. And the last term will be Tn because we must substitute the top value. And if you want to get the number of terms in a series, so when you are doing Sn, so this value of this n, it will be the last value, the top value, minus the first value, the bottom value, plus 1. So let us look at some examples to further elaborate this idea. So for example 1, you are given a series, but the thing is with this series, you don't know what type of series it is. So whenever you are given a series in sigma notation, the first thing that should come to mind is expansion. So you need to get your series written in terms of first term, second term, third term, and so on. So you must substitute 1. So you don't need to write this, but I'm just showing you. So you substitute 1. So you'll have 2 times 1, which is 2 minus 6. That will be minus 4. So that will give you minus 4. And then you move on once more and you say if you substitute 2, so that would be 4. 4 minus 6 is minus 2. And then if you substitute 3, 2 times 3 is 6. 6 minus 6 is 0. And maybe you can do a fourth term, but you don't have to. So 2 times 4 is 8. 8 minus 6 is plus 2. And this series goes on up until the last term. So you can do the last term or you don't. It doesn't really matter that much. What we are focused on is finding the identity of this series. So minus 2 minus minus 4 will give us positive 2. 0 minus minus 2 will give us 2. 2 minus 0 will give us 2. So now we are sure that we are dealing with an arithmetic series. And because we are dealing with an arithmetic series, we can use Sn equals to n over 2 into 2a plus n minus 1 times d. And this is in your data sheets. So the problem is we don't know how many terms we have. We need n. So to get that, we say the last value, that's 10, minus the first value, which is 1, plus 1. That was the formula that we were talking about earlier, this formula. So 10 minus 1 plus 1, that would be 10. So the sum is the sum of 10, 10 over 2, 2 times a, it's minus 4. So this is 10 minus 1, and our common difference is 2. So the sum of 10 will then give us a value that you can determine on your own. Right. The second example is another interesting one. So you are given once more the formula here. So because you are given the formula here, we can then determine the series. So you start by substituting 1 here. So you'll have 5 into minus 2 to the power 1. So that will be minus 2 times 5, which is minus 10. So that means your first term will be minus 10. And if you do that for the second one, you'll get positive 20. Then you'll get minus 40. Then positive 80. Minus, and so on and so forth. So if you try and find the difference here, 20 minus minus 10 is 30. Minus 40 minus 20, that will give you minus 60. So already you can see you don't have a common difference. So you need an alternative. So what we'll try and do here is we'll say 20 divided by minus 10, that will give us minus 2, and minus 40 divided by 20, that's minus 2, 80 divided by minus 40, that's also minus 2. So that tells us we are dealing with a geometric series. So because we are dealing with a geometric series, we can use either of the two formula. Now, again, we need to find how many terms are we adding. So n is the top value minus the bottom value plus 1. So again, that will give us 8. So the sum of 8, the first term is minus 10. R is minus 2 to the power of 8 minus 1 all over minus 2 minus 1. Plug this in your calculator. The sum of 8 terms will come back to give us a value. Let's see, a value of 510. Moving on, we move to another example. So interesting, because now we have something going on here. Maybe let's use yellow. We have something going on there. We see infinity. So we are starting from 1 and ending at infinity, and this is a sum. And if you combine those words, it's sum to infinity. So we expand, of course, that is the first step. So when you expand in this particular scenario, again, you have 2 times 4 to the power 1 minus 1. So 1 minus 1 is 0, 4 to power 0 is 1, 1 times 2 is 2. And then if you follow the same process, the following term will be 1 over 2, and then the third term will be 1 over 8, and so on. And if you find the ratio, because now you know you are dealing with a sum to infinity, and sums to infinity are geometric series, so you'll find the ratio of 1 over 4 and 1 over 4. So that is your constant ratio. So sum to infinity is a over 1 minus r. The first term is 2 1 minus 1 over 4, and the sum to infinity will be 8 over 3. Moving on. Another interesting problem. They are saying if this sum is equal to 1640, determine the value of n, which is this one. So now this is an interesting problem. So let us see what we need to do. Firstly, we need to expand. So we need to substitute k equals to 1 here, k equals to 2, and k equals to 3 to get our first three terms. So our first three terms will be 1 over 2 plus 3 over 2 plus 9 over 2 and so on. And we are told that eventually when we add all these terms, we'll get 1640. Now, we can then try and see whether we have a common difference or a common ratio. And in fact, we have a common ratio because if you say 3 over 2 divided by 1 over 2, you'll get 3. And if you say 9 over 2 divided by 3 over 2, you'll also get 3. So sum of n terms will be a into r to the power n minus 1 over r minus 1. We are given the sum. The sum is 1640. The first term is 1 over 2 into r is 3 to the n minus 1 all over 3 minus 1. So this will give you 2, and you need to multiply by 2 on both sides and then divide by half. So if you do that, you'll get 6560 equals to 3 to the power n minus 1. So you just have this part. Half divided by 2, that's 1 over 4. Multiplying by 1 over 4 or dividing by 1 over 4 on both sides, you get 6560, and you are left with 3 to the power n minus 1. You transpose this minus 1, you have 6561 equals to 3 to the power n. This 3 is a clue that this number on the left hand side must be raised to power, must have a base of 3 rather. So it's 3 to the power of what? That is your question. So if you do that, whether you use your calculator or you do it by trial and error, you'll find that you have 8. So 3 to the power 8 will give you 6561. And because the bases are the same, n will be 8. The last question. Now, I always tell students this. Whenever you are taught something, they will also want to ask you in reverse. So all along we've been given the sigma notation, but now they say we must write this series in sigma notation. So now this is a reverse challenge to the challenge that we had. Now a sigma notation, we said it has a general term Tn and the start value and the last value at the top. So we need Tn. So to get Tn, we need to first identify what type of series we have. 4 minus 12. So if we say 4 minus 12, that will give us minus 8. If we say minus 4 minus 4, that would be minus 8. So this means we have an arithmetic series. So if we have an arithmetic series, we can use Tn equals to A plus n minus 1 times t. The first term is 12, n minus 1. The difference is minus 8. So this is 12. Minus 8 times n is minus 8n. Minus 8 times minus 1 is plus 8. So finally we can say Tn is minus 8n. 12 plus 8, that is 20. Right. So we have this part covered. So if we substitute 1, so that would be minus 8 times 1 plus 20, which is 12. So it means we must start at 1. But now the question is, what term is minus 276? We can use our general formula and say minus 276 equals to minus 8n plus 20. Bring this one this side, it's 8n, and then you have 296 on the right hand side. So divide by 8 on both sides, you will get 37. So that tells you that minus 276 is term number 37. So we can go and then say our series will be sum of minus 8n plus 20, starting at n equals to 1, ending at n equals to 37.